For the CircuitPython Parsec today, I wanted to talk about setting up a basic MIDI keyboard in CircuitPython using a trellis. This is a mecha trellis. You can use this with a NeoTrellis. You can use it with a regular trellis. But the fundamentals of using USB MIDI to just send note on off. So here's a little demo. I've got a number of octaves of keys here that I can play, almost well, 64 keys, so getting pretty close to a full piano keyboard there, not quite. And so the way this works inside of CircuitPython, key things that are going on is I'm importing the USB MIDI library and the Adafruit MIDI library, along with Adafruit MIDI's note on and note off. I've also got the usual NeoTrellis and multi-trellis setup. This is set up like four little 4x4 pads just connected together. A little variable here for the number of switches. I do I2C setup, and then all of the four addresses of that trellis get connected. And then I'm setting up MIDI. So here, MIDI equals Adafruit MIDI, MIDI out. What port's it going on? It's going out on USB MIDI port 1. And the out channel, out MIDI channel. You can have 16 of them. I'm on channel 0, or what's called channel 1 in the MIDI world. And then I'm setting up some other of the trellis LED things here. So I have a brightness value I'm using of 0.3. And then I have a number of color definitions for these rows, as well as, you can see there, a brighter color when a key gets pressed. So those are those two little lists there that I put into the row colors and row dim colors. And then I have some MIDI note mapping helpers. So these are set up on the trellis as key 00 and key 77. I'm going to flip that around and call these 0 through 1, 2, 3, 4, up to 63. So my MIDI helpers are going to take those and grab different notes. I have all essentially of the white keys per row, so that's this little key intervals right here, key 0, 2, 4, 5, 7, 9, 11, and 12. So we get the octave with just the white keys. And then my first note here is a C1 on a piano, or MIDI note 24. Then I have these calculations from the grid system to the number system and vice versa that we've looked at before. And then I have this get MIDI note, which essentially takes that and converts to one of those MIDI numbers. And you can see in my REPL here, when I do press a note, I'm printing out a bunch of stuff here just to make it a little easier to follow. So the bass note, that's always going to be 24. That's where I'm starting. I add to that the octave number, so octave 0, 1, 2, 3, 4, and on, and multiply that by 12 so that I get a note number to add to it. And then whichever the X coordinate is, the white key intervals on X, so 0, 7, 12 going across. So that get MIDI note takes in an XY position and spits out a MIDI note, which you see printed there. And then I have a little display initialization. And then this is the callback that gets called whenever I press a note. So this is the main thing that's happening when we press a key. We send a X and Y position, and we also say, are we pressing it or is it being raised? So push or release. That's the edge detection there, or edge state. So then we get that position and that note. If it's being pressed, which is rising in this case because of the pull-up resistor, then I do a MIDI send note on, note number, and a velocity of 127, or full volume, full velocity. Then I also set the color to the brighter version of the color of that note, and then I'm printing it out. When I release, we just send this MIDI.send note off, the note number, and this velocity of 0 is kind of redundant. There's a couple ways that can be done, but just for clarity, I'm sending a note off and a velocity of 0. So these are the keys right here: MIDI send note on and a note number and a velocity, and MIDI send note off. That presses and turns off a note in whatever synthesizer you're using. And then we set up all the buttons so that they have that edge rising and edge falling state that can be checked. And we name the button handling function. So when one of these is pressed, this is the function that gets called handle button, which was the name of this guy right here. So with all of that set up in the main loop, all we have to do is trellis.sync, and that is just constantly, or every 2 milliseconds, polling to see are any of these buttons experiencing a state change from rest to rising to falling. And so that is how we can play a whole bunch of MIDI notes on our Trellis device inside of CircuitPython. And that is your CircuitPython Parsec.